So let's do the y-intercept first. So for the y-intercept, I'm going to have you go down the entire column and do all of the y-intercepts. I need to plug in 0 for all the x's, right? So I would get 0 on top, and I would get positive 8 on the bottom. What is 0 divided by 8? 0. So I plugged in 0, and I got 0 as the output. Can you try plugging in 0 on the next 3 functions? So go down the page, do all the y-intercepts. So plug in 0 for all the x's, be able to kind of do the calculation without needing the calculator. So -4 over 8 reduces to -1/2. So 0, -1/2 would be my y-intercept. It's okay to have a y-intercept at a fraction, right? You would just go to -1/2 is between 0 and -1 on the y-axis. This would just become 5/4, right? So 0, 5/4 because this 8x goes away. And then what happens on the last one? I get 1 in the numerator. I get 0 in the denominator, which I'm not allowed to do. So there is none. There'd be no y-intercept. And a graph might never cross the y-axis. Okay, so that's rule number 1. We're going to use that as rule number 1 for this whole unit. How to find a y-intercept, plug in 0 for x. It'll be on your note card. We've done 8 of these already. Let's see, x-intercept. So each time I'm going to take my numerator and set it equal to 0. So the first one is done for you, right? Because if x has to be 0, then x is 0. So 0, 0 would be my x-intercept. So now I'm going to write down the next numerator is 2x minus 4. How do I solve that for x to make x help me make 0? How would I solve that for x? Get x by itself. So add 4 to the other side, right? Algebra. So 2x equals 4. Then what would I do? Divide by 2. So x equals 2. And now I have to remember I'm finding an x-intercept. So when x is 2, comma, y will be 0. What happens on the third example? I get 5 equals 0. Does that make any sense? No, 5 will always equal 5. So 5 will never equal 0. So it has none. It might have no x-intercept. Okay, then the last one, 1 minus x equals 0. What would x have to be to make this true? Positive 1. Add x to the other side. X would have to be 1, so 1, 0. That is 2 out of the 5 steps that you need to graph a rational function. You have to be able to find the x and y intercepts. So the next part that I wanted, can I move that now? I'm going to give you, so there's a blank page on the back of 204. See the blank page? I'm going to give you 2 division problems I'd like you to try. So division problem number 1, you could write down x squared plus 5x plus 1 all over x minus 2. See if you can divide it. And the other one, we will do x cubed plus 5x minus 3 divided by x squared plus x plus 7. So number 2 is going to be more challenging. Number 1's kind of like the starter kind of problem. If you've been here for a few days, see if you can set up your second box and do your division of a quadratic. Cubic divided by a quadratic. I'm going to give you a few minutes. We've done 12 division problems together. So set up the second one together. You put x minus 2 down the side. Thank you. And then you put x squared inside that first box. And you ask yourself, this is going to be my quotient up here. What times x is x squared? So x. And x times -2 would give you the -2x in the bottom of this box. We're trying to get to 5x's. I'm currently at -2x's. So what has to get added up in that other circle? 7x's plus -2x's will add up to the 5x of my dividend. So x plus 7 was the correct quotient. I do 7 times -2 is -14. It looks like 15 would be my remainder. So, whoops. So x plus 7 is the quotient, and then 15 is the remainder, because that's how I get to, I have to get back to this positive 1 over here, right? I'm currently at -14, plus 15 gives me 1. All right, let's see if you could set this one up okay. So my divisor goes on the outside no matter what my problem is. So my divisor is x squared plus x plus 7, oops, down the side. Do you see a term missing from the original dividend? See how I skip over a term? So I'm just going to write above it so I remember in my head, I have 0x squareds in this original problem. That's going to be important for a step down the road here. But my first dividend term is x cubed. So I'm going to put x cubed in the first box, top left. And I can do my quotient is going to show up here. So x times x squared is x cubed. And now you're going to multiply to get the two lower boxes, x times x, x squared, and x times 7, 7x. So you put your dividend in the top left, you figure out what goes in your quotient, and you multiply all of them all the way down. So now the important part to look at is what I had written up here. I have 0x squareds in my dividend. I currently have x squared inside this box. What gets added in that other red circled box? These have to add up to 0. So I need -x squared so that the two red circled boxes add up to 0 of them. And now I can do the last term of my divisor. What is the last term of my divisor? What times x squared is -x squared? -1. So my whole quotient is x minus 1. That's as far as you need to be able to get to do an asymptote line next week. So what times x squared is -1x squared? So that's where the -1 comes from. All the rest would be awesome if you could find the remainder. So I would get -x, -1 times x, and I'd get -7. See if you can figure out what the remainder is. So when I sweep this diagonal all the way across, it has to add up to 5x. And when I sweep this remainder across, it has to add up to this -3. So see if you can figure out what would I put where those two stars go so that my this sweep should add up to 5x, and this sweep right here should add up to this -3. Because it's just practicing division. So even if you don't need the remainder, you have a strong understanding if you can find the remainders. So it looks like you would just need another -x right here. So you have a 7x minus x minus x. Wouldn't that give you the 5x that you're looking for? And you have a 7, subtract 1, you're at 6. Subtract another 1, you'd be at 5, right? So your remainder is this -x. And then what would go here to get to -3? You'd have to have a +4, right? So your remainder would be -x plus 4 if I actually wrote it out. -x from this box, +4 from this box. This is a harder problem that I would probably have you do, but you could find a problem that's a cubic divided by a quadratic and have to find your quotient. Okay. Can I show you one more page? I want to do one more division problem. Let's see. Can you skip to the next page of 205? So there's other rules that come before this, but I want to show you a problem where you're going to be doing division in rational function world. So let's just skip ahead. Let's do one more kind of division problem. This says if the largest power of x is in the numerator, there will be a slant asymptote. See how there's an x squared in the numerator and an x in the denominator? This is another division problem. But when you look up above it, see how you have a 2x plus 5 and a 3x minus 2? You wouldn't do division on this problem, right? Because you have a linear function and another linear function. Same thing with up at the top. 1 divided by x. Can I do division? No. So your brain is going to get trained to be like, oh, that's a division problem. X squared dividing by a linear function. So you know how some of you are having problems like identifying what type of function I do what type of factoring on? Hopefully your note card will help you for this unit, but you should be able to tell, can you do division or can you not do division? I can do division on this. Let's just skim really quick. I'll just show them. You tell me, could I do division on this one? No, I've got an x and an x. I wouldn't do division. What about the next one down? Should I do division on this problem? You just look up here. X divided by x squared. Should I do division? No. What about this next one? Should I do division on this one? X squared divided by x. So you're looking for where the numerator's bigger. Yes, you might be able to factor some of them, but you might still have to do division. We're not factoring this one. 7 is a prime number. So, all right, do that last problem for division for me. So you're taking I'm back to the back page of 205. I'm picking one more problem that we can do division on. And I want you to see if you can do division with the box method, hopefully. As our last problem on this Friday here. You have to know when to do division, and you have got to be able to do division. No, because we're only putting x minus 3 down the side, right? X minus 3 down the side. X squared goes in the top left. See if you can do the next step. What's my next step? Maddie, what would I do next? Help me finish this one. What do I do next? Yeah, what's thing? We're not factoring, we're doing the box. So how do I figure out what goes up here? Okay, so what goes there? Okay, I want to make sure you know how to do it, right? So that's good. Grace can multiply. X times x is x squared. How do I get the next box on the bottom, Carly? How do I get this box right here? Negative 3x. Who can tell me how to get the next diagonal? Who's telling me right now? Is that Addie? Oh, Carmen? Yeah. Y plus 5. See that 2x right there? I'm currently sitting at negative 3x in the hole. I need to add 5 x's to get to 2x. Almost. What's my next step? Now I have to do this other part up here, right? So what goes up here in my quotient? Positive 5. That's really all I care about in rational function world. My final answer is y equals x plus 5. That's my asymptote. What's my remainder if I want to check for a remainder? I would do the negative 15 in the bottom, 5 times negative 3. What do I add to get to positive 7 though? So my remainder is 22. That doesn't show up on my graph. So my asymptote is y equals x plus 5. So if you're not feeling